Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we are going to be talking about the downfall of the no calculate approach. That's right, after years of people trying to tear this approach down and they bad mouthing it and everything else, and where it's in, ever since it was kind of put on the map by Brian Julius, really, people have been trying to say, oh, it'll never be as fast as calculate. Oh, it won't scale. Oh, you can't do all except. And despite all of these attempts, all this hate that it's received since then, and trust me, I know all the hate because I've been been directed at me in large part. Despite all of that, it has the no calculate approach has weathered every storm and passed everything with flying colors, in no small part to Tamer Juma, who is like a no calculate genius, next level talent. And he features in a large part in this video as well. Big shout out to Tamer Juma for answering my LinkedIn messages. And so you'll see later in this video the part that he has to play in all of this. But thanks, it's weathered every storm. So it's with kind of a lot of satisfaction to me that and I don't think I'm boasting when I say I was the pioneer of the no calculate approach to DAX, that I'm the one to find its Achilles heel, if you will, after all of the haters couldn't. So, all right, and this video didn't really start out this way. It really started as just I was doing some work for a pro bono customer, and don't get any ideas. I have like one pro bono customer. So I was doing some work for a pro bono customer around this interesting issue, and decided to kind of really dig into it in some spare time that I finally found. And so the scenario really is something that's really kind of mundane and kind of seemingly trivial. And that is basically given a table of, let's say, people that attend events, right? So you have an ID and you have, event dates. Given that table, find, the people that attended events on this date, but not on this other date. Okay, that's really the entire setup for this. And so just real briefly to take a look at the data. So, I have a table of dates in 2023, table of dates in 2024. I have IDs for 2023, which I do. Basically, it's a list of IDs from 1 to 1,000. And then in 2024, I've engineered it so that it goes from 1 to 998. So I'm always going to have two, just regardless of what date I pick in 2023, I will have two people that are missing in 2024 is the idea, right? Numbers 999 and 1,000. So then I can, basically join those up so that I do a Cartesian product. So I have every ID on every date, in 2003, same thing for 2004. And then I can combine those, right? And so I have a single fact table, and I combine the dates, so I have a single date table. Easy, right? So that's the setup for this. And the other thing that you're going to see about this video is we're going to take a very methodical approach to this. This isn't the, where you like, have the, you have to set up the problem and then, oh, here's the solution. And you kind of, miss all the steps along the way. This video I've set up to be very much kind of step you through this process of figuring this out, which I think it adds a lot. I think a lot of times when you just have a video that just says, here's the problem, here's the solution, you miss a lot of learning and the wisdom that comes along with it. So bear with me. Some of these data models are pretty large. I can't load them all up into Power BI at once, or my computer would just be brought to a crawl. But anyway, so we're going to go through this. So first, naive, and we're going to do things wrong, right? So that, I don't know, just so we can talk about, how to solve this problem and why the solution ends up looking like it does, right? So in a naive kind of thing, right, I have a single date table and a single dates table in my fact table, one-to-many relationship between them, right? I can put two slicers on the page, and probably everybody's like, of course this isn't going to work. Well, of course it's not going to work. But I can select 2023. But the problem is, right, because it's a single date table, it filters out my other slicer, and so this is a bad model, right? So let's go ahead and close this guy down because it's not even going to work. Yeah, sure, save it. All right, so that brings us to our next one, which is events 2. And in this case, what I've done is, okay, Well, I'll have two date tables, right? And I'll have one, that solves the problem, right? And I have a relationship here and a relationship here. And I can go here and select 2023, and then I can go over here and select 2024. But of course, there are no rows, right, that match both 2023 and 2024 from both those date tables, right? So I get this blank right here, because everything's filtered out at that point. Because there is no row in the table that has a date of 1/1/2023 and 1/1/2024, right? Logical. All right, so that one's a no-go either. Save it. All right, we'll go move on to event 3. So how do we solve that? So let's just say, let's just remove the relationships, right? And I have my table, my date tables here. Now I can select 1/1/2023 and 1/1/2024. I can select any date in 2024, and as you can see, it brings back 999 and 1000. And this is a complex selector, which I covered a couple videos ago in solving problems on the forum, right? So what you can see here in this measure this is pretty classic no calculate approach, which, by the way, if you're not familiar with it, it's create a couple vars, create a table var, use an X aggregator or some kind of aggregator, right? So in this case, it's a very similar approach to that. So I grab the ID, right? I grab my first date. I grab my date for my second table. I do a select columns where I filter, for the ID for that date from the table. I do a select columns where I filter my table for the date on the second date, right? I can do an accept across them. And then in this case, I do if ID in table, 1, otherwise return 0. I could also do a count rows here as well, but this is just how I set it up in these initial preliminary versions. And so as you can see, if I go into Performance Analyzer and I do start recording and I refresh the visuals, it performs extremely fast, right? 100 milliseconds, very fast. Now, as you can see here, if I can get down here, so that's my dates table. If I do my fact table down here, I've got almost 1 million rows in my fact table. So it performs, very fast at that scale, if you will. Now the problem comes is when you scale this up, and this was the problem that my pro bono customers running into, is that they have a fact table that involves millions and millions and millions and hundreds of millions of rows, right? So if we close that, we can go ahead and save it. That's fine. We get to this one, right, which is the same setup right here, right? But what I've done here, I need to open it up on the wrong window. This over here. So what I've done is I've scaled this up. So if I go to my D's table here, so instead of 1 to 1,000, now it's 1 to, I think that's 1 million. My eyesight's getting bad. Yep, 1 to 1 million. And then my D's 2024 is 999,998, right? So still two IDs, right? So go ahead and close that. And now if I run this, if I pick this guy and pick this guy, and we'll sit here and wait. We're probably going to wait probably about 14, 15 seconds for this guy to return. While we're waiting, go ahead and bring up Performance Analyzer, and we'll wait some more after we get this. There we go. It finally came back. There's 1,990,000. So if I just hit start recording and do a refresh on visuals, we can sit there and watch this thing spin, and we'll get a timing on how long this thing takes. This is like when the Jeopardy music plays in my head, by the way. Okay, so 22 seconds. 22 seconds to come back with that result. And in this case, right, we've scaled up our fact table. So we have 730 million, almost 731 million rows in this fact table. And so that approach of using two disconnected date tables falls flat, right? Doesn't work very well. All right, so now we're going to have to start opening reports. So I've got all of these saved here. So events 5. And we'll go ahead and close this guy. Sure, go ahead and save. It's coming. That's my Discord discussion. That's on the definitive guide to Power Query M, right? And then maybe some of you guys don't agree that no calculate is divisive. I've definitely felt it. um, uh, so I don't know. I wrote the book, DAX Cookbook, it's been over 4 years ago now. It came out in March of 2020. I didn't really think anything of it. Didn't really have a term for it other than that's just how I write my DAX. And it really did kind of took off. All right. After an enterprise DNA video I made, and Brian Julius kind of picked it up and ran with it. All right, so now what we've done is I've created one relationship to my table from my original date column. My second date table is I have no relationship. So now what we can do is we have the same, I don't know why I have table 2, that's an artifact of, doesn't matter, I was doing something else apparently. Same basic measure, right? So select columns, table ID. Oh, my bad. All right, so one way to fix this. Forgot about this one. One way to fix is, well, what if we duplicate our fact table? And we have one fact table connected to our dates table and the other fact table connected to our other date table. So basically, these are just duplicates of each. This is just a duplicate of this. This is a duplicate of that, right? We wire them up this way, and now we can have our measure. So we select at a table, and we select at a table 2. We do an accept across that, and then same thing. And again, I could use count rows in there, probably be even faster. We get the result back, right? And performance analyzer, start recording, refresh visuals. And now we've got it down, from 22 seconds down to 5 seconds. Still not blazing fast, but definitely, 4 times better than the previous way that we were doing it. Now, the downside, obviously, to this approach is that you've duplicated your fact table, which is your biggest table, and it just really blows up the data model size, which, let me bring this up here. I've got another screen. I'll bring it down here in a second. So essentially, what you can see here is that the original data model was under a gig, right? Just barely, but under a gig. That means we could publish it up to the Power BI service. But now that we've duplicated our fact table in Events 5, it's almost 2 gigs, which is, unless we're using premium or something, is going to cause problems. Or if you use my poor man's premium approach, maybe you could do something along that, along those lines, and break the semantic model up. But not optimal by any stretch of the imagination, right? So let's throw that approach out. That's not a good approach either. So now what we'll have to do is say open 6. Close this down. And don't save it. We didn't really do anything. Okay, we're on to 6. We only got a few more of these to go. This is why, I couldn't have all these 9 or 10 data models open in time. They're each like a gig or 2 gigs. So couldn't really have them all open at the same time. So you just have to suffer through some loading screens with me, except that you will have the benefit of being able to just fast forward ahead or watch this in 2x speed or all the fun things you can do on YouTube. I cannot do that, unfortunately. Okay, so in this approach, I decided to say, okay, we're going to go back to our single fact table. We'll have 2 date tables, and they'll each have a inactive relationship with the fact table. Okay? So in this case, I can create a construct a measure to do a select columns, calculate table, use relationship, right, of my first date table. Do the same thing, but use the relationship between my second date table. I can do an accept across them, same blah, 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 right? Pretty simple stuff. And then we bring up performance analyzer, start recording, refresh the visuals. Okay, so not as fast as having two fact tables, faster than having no relationships at all. But we're still sitting here at 12 seconds, which is a long time. So that's, we're gonna have to throw that approach out as well. So on to the next. Fast calculate table. Close this down. Wait for this to load. I knew this was going to be a lot of waiting in this one. That's why you don't normally see me with anything in my hands drinking, but that's why I brought my water, because I figured this was going to be a little bit of waiting and watching what's going on here. Okay, so this one's coming up. So the last one was about 12 seconds, right? With basically two inactive relationships between the two tables. Now you can see that one obviously was faster. So all we did in this one is we changed one of them to be active and the other is still inactive. Okay. And our measure is actually pretty much exactly the same, except that we don't have to use a use relationship. We can just grab the IDs. We can then do the same thing, but use calculate table to use relationship, use an except, if, blah, 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 same kind of concept, right? And when we do that, right, there you go. 1.4 seconds. Now the DAX square on that's 1.3 seconds, so that's the majority of it. But a huge improvement, right? Just by having that one active relationship, which seems a little weird to me, I guess, in terms of I thought, I was thinking, well, if we create one, if let's say that both of the big time sink and all this is selecting the data out of the fact table. We have two inactive relationships. In the last one, it took 12 seconds. Okay, let's say that's 6 seconds per. I was expecting this to come back within like half of the time. But it did much better than that. It came out back at a factor of 10 faster, 10 times faster. So by having that use relationship, just having one active relationship to it and the other being inactive. Okay, and it's even faster than anything we've done, anything we've gotten to so far, right? It's just blazingly fast. Okay, but of course I am not, I am the no calculate guy. So I like having things that you can do without using calculate. So let's go ahead and go on to 8. And we'll close this one down. All right, so 1.4 seconds, fastest time we've had yet, at least at the large data model size, semantic model size. We'll let this one load. Okay, so in this model, I have the same model as I had in previously. I have one active relationship, one inactive relationship, right? And I've got my dates and then my measure. So this version of it is the same logic, right? Where I select, right? In this one, I do a select columns, filter, summarize all, and do it that way. And then this other version of it, I don't include the summarize. And it's kind of interesting. This is where we started getting some kind of interesting results here. But let's go ahead and bring up Performance Analyzer on this. Start recording, refresh the visuals. Okay, so about 4 and 5 seconds, right? So okay performance, not the greatest. Now what's interesting to me is the one that includes the summarize, right? Performs about a second faster than the one that doesn't, right? Almost a second faster. And that seems very consistent. So if I look at these, right, it's always faster. Sometimes it's about half a second, sometimes it's a second, somewhere in that range, but it always seems to be faster. Now, the other thing that I found out about this is that this is good, Performance Analyzer is good for comparing measures to one another, but it's terrible about comparing this type of measure to our previous data model, right? And hopefully I could show this here. So we're getting back 3.5 seconds on this measure. So let's go ahead and clear this. And if I remove this, at least I was getting results. Yeah, so it knocked an entire second off of it, right? So now it's not quite as bad as, so we're getting about 1.4 seconds on the calculate table, and the no calculate, it's right around 2 seconds. So very comparable in terms of performance, if you will. The interesting thing, again, that there must be some contention going on when I have multiple measures that are all trying to access the same thing. And what we can do so we get about 2 seconds on that. Let's run this a couple more times. Yeah, right around 2 seconds. And most of that is the DAX query, right? For sake of completeness, right, we can replace this measure with our other measure. We'll go ahead and clear this, start recording, refresh. So definitely seems longer, right? It's about comparable, but something about the summarize is summarize just for whatever reason, throwing that summarize in there really tends to speed things up, at least somewhat. We're gaining almost half a second on the DAX query, right? So so this is it's about right here, which I'm like, okay, this is interesting so far. But still calculate table still like 1.4 seconds, and the best measure I have is still 2. It's comparable performance, but it's not the greatest performance. It's still not faster than calculate, which calculate table is a substitute for calculate in this case. Yeah, so again, comparable performance, but not faster. But this is where, how could I optimize this even further? And I know my limits. I'm not the DAX optimization guru. That is not what I do. Um, I just create solutions for DAX. I don't really worry about optimizing too much. But I do know somebody that is fantastic about optimizing no calculate measures, and that would be Tamer Juma. So I reached out to Tamer Juma on LinkedIn, and he came back with some pretty nifty improvements to the DAX code. So let me go ahead and pull up. I don't think it's the final, but we have just one more to go after this one. Close this down. No, I don't want to save it. We only have one more loading screen after this to suffer through, people. And this is not a terrible machine. It's like a Surface Book, I don't know, 5 or something like that. I don't know. It's pretty recent, maxed out memory and all that. But it does have its limits. Trying to run teams and big Power BI models and all that kind of fun stuff. Any machine, that's not a desktop class machine or server class machine is going to have some issues. Okay, so Tamer came up with, I think these are, measure 2, measure 3. Okay, so again, we're going to run the performance optimizer, and then the way these look, they're very similar, right? So select columns, some filter, summarize, blah, 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 count rows, except. So he's got the count rows improvement in there. That's that measure. Measure 2 takes out the summarize, or measure 3, I guess it is. Measure 2, measure 2 takes out the summarize. Measure 3 does very similar. I'm not sure I see the difference between this guy. Oh, summarize versus. Oh, that's right. Distinct versus values. So that's changing distinct versus that I might have been the one messing around with that. I'm pretty sure I think Tamer came back with values, and I was messing around and trying to use distinct. So anyway, so let's go ahead and first see which one of these measures is faster. Performance analyzer, start recording, refresh visuals. Okay, so this one is least faster, and this one is measure, the one that uses distinct and summarize. We'll refresh again. So again, faster, always consistently faster. So this is the reason why I mentioned that in my experience, like distinct just seems faster than values. That's the only difference between measure 3, which is this one, that's taking 2.5 seconds, and the DAX query is about 2.5 seconds, right? And this one, where the DAX query is sub 2 seconds, right? That's the only difference, is that this one uses distinct and this one uses values. That's it. That's the only difference. Um, so that's what I mean when I say people use distinct, don't use values. You're costing you guys performance, in my opinion. So what we can then do to compare this, right, is we can get rid of this guy, get rid of that guy, and we're at 1.4 seconds, as I recall, was our fastest time. So let's go ahead and refresh our visuals without those other two in the way. And look, that's our best time yet. So we're at 1,000 milliseconds, or 1 second, right? Oh, we're even sub 1 second, right? Really good performance. Now we have a no calculate version that performs even better than calculate, except, of course, Tamer also came up with a better calculate table. Let's get rid of this guy. Well, I don't know why I did that. Just this is measure 4. So calculate table, distinct, all, use relationship, right? And then it does result of count rows except distinct table ID and table 2. And if we use that measure here, so we did get a sub query right here of 888. In this case, well, let's go ahead and refresh the visuals. 870. So now basically it's 800 milliseconds, right? So, but they're still extremely comparable as far as between those two measures. There's almost no performance difference, which makes me happy, right? No calculate, yes, once again, has beaten back the no calculate haters, and is successful. Except this works really well, and you can get these performance gain, the same performance if you're using one date, right? You're comparing this date to that date. But what if you wanted to select multiple dates? And this is where the no calculate approach falls down, perhaps surprisingly. And I'm gonna show it to you, and then I'm gonna show you the work that Tamer did to show what is going on behind the scenes and why it's falling down. So let's go ahead and bring up this. So if the people that are the no calculate haters, if they just skip to the end part of this is the part that you want to watch, so you can say, yes, we were right all along. No calculate sucks and it's terrible, right? No, we won't say that. All right, last loading screen we got here. Load. Okay, so as you can see, I picked multiple dates in 2023 and multiple dates in 2024. And there it came. And so what we're doing here is we had to switch up our measures a little bit in order to account for multiple dates versus can't just do equals date, right? You have to do it a little differently. So anyway, so in this case, we're doing calculate table distinct, and then we do account rows except, right? This really hasn't changed from the last one. Now, the no calculate version has changed a bit, where we do count rows, filter, distinct, is empty, filter, treat as. This not empty measure is really just returns false. So not is empty table. And these are measures. The last one that I showed you, those were Tamer's measures. I don't want to take credit for those. And these are also Tamer's measures that he came up with. So as you can see, then if we go to view and then performance analyzer, we start recording. Let's refresh the visuals. As you can see, so it gets worse and worse. The more dates that you select, the no calculate starts out kind of on par, but then as you select multiple dates and more dates, it just exponentially grows and takes longer. Where versus the calculate table version, a sub 1 second, and now even just with having 3 dates here and 4 dates here, we are up to over 3 seconds, right, for the DAX query. So maybe you're wondering, well, what's going on exactly with that? Well, luckily, Tamer has told us because he did the research on it. So basically, if you read this, so he had some time. So I posted this and took several days, and I really appreciate Tamer digging into it as much as he did. I really didn't expect him to really, but he obviously spent some time on it. And he said the reason for this is very obvious. The formula engine built in optimization strategies were clearly developed following the calculate approach. Applying fillers and no calc approach wasn't even looked at. And this is what tells the tale of the tape, if you will. So what you're seeing here is from DAX Studio, obviously, where basically the calculate table version, when it does this, it goes out and it groups it by ID only, right? So while it keeps dates in the filter, all the calculations are pushed to the formula engine. So best performance. Versus in this version, the no calculate version, for some reason, it insists on including the ID in the filter, but basically filters all of the 1 million IDs. This is why it's included in the included ID in the grouping by, right? So groups by both ID and date, right? So it actually, you can see it's got 1 million total values. So the best we're able to achieve is to include the date in the filter of the query. However, the more dates selected, the larger the cache becomes. In the measure versions that exceeded limitations, because we went through a couple of these, like where we tried to use the in operator, bad idea. That just basically exceeds the memory limitation like immediately. Query basically caches the complete fact table, right? So he went in here and okay, so I suppose that you could say that, well, this isn't really a failure of no calculate. This is really a failure of the, DAX query optimization engine, right? Now, even I would not be so petty as to say that, right? Because I'm the one that has been arguing that point all along that, look, the DAX that you write is not what gets executed, right? That gets translated into a query, and that the optimization of that underlying query is what really gives you your performance or non-performance. So you can write whatever DAX you want, as long as the query engine can translate that into something that it makes reasonable performance to grab it from your data set, then you're going to have good performance, right? Whether you're using calculate or calculate table or the no calculate approach, because you don't have any control over this, right? This is all done by the DAX engine, by the bowels of the DAX engine. It's very similar to how you write whatever SQL you want, as long as the SQL engine can optimize that to retrieve the data, the way that it figures out as far as its query plan, then it's all good. It doesn't matter how inefficient your SQL is, as long as the SQL engine can optimize it. So I would never be so petty as to make that argument. This is a case where the no calculate approach just doesn't live up to what you can get with a calculate table approach. Calculate table being the surrogate for calculate. So even I'm not as petty as to make that argument. And trust me, I am no slouch when it comes to the petty department. I am the person that re-implemented the meme campaign after I was summarily dismissed from the MVP program, and I wasn't even upset about being summarily dismissed from the MVP program. But I thought, man, what the heck? If that's what got me fired, then great. I'll just start it back up. There's nothing more they can do to me now. And just for all of you that have held on this long to see all of this long video, I will regale you with just how petty I can be. So back when I was in my 20s, my brother and I had a much more contentious relationship than we do today. And he had joined a country club, very fancy country club, and he wanted to have Easter brunch there. And so he was on the phone with me, talking to me about having Easter brunch. And at the end, he just throws in this comment of, and Greg, just, make sure you dress nice. Ends the call. Well, I took offense to that. And now, in retrospect, my brother had all the reason to be concerned about his younger brother showing up and embarrassing him at his fancy country club. So that was justified, but I took offense. How dare my big brother, think I'm going to show up in like sweatpants and a t-shirt to his fancy country club. So I had a long time to prepare for this. So the day Easter arrives, I arrive at the country club, and I show up in a bright red crushed velvet suit, along with a bright white silk tie, and black and white wingtip shoes. So now my brother, he could say anything he wanted, but not that he could, because he was left literally speechless. Um, you know, he couldn't say that I wasn't dressed nice, especially after all of the wait staff within the country club went out of their way to tell me how nice I looked in my suit, and just how sharp and dressed to the nines and all of that. So that is how petty I can be, and the lengths that I will go out of my way to be petty. So that's all I had for this video. I hope you enjoyed it, and I'll see you next time.